Okay, guys, for today's lesson, you need this sheet that says dividing radicals. So far we've added, subtracted, and multiplied radicals. And today we're going to talk about dividing radicals. So if you look at all these problems, all of them kind of have something very similar where you have a radical in your denominator. And a radical in your denominator is pretty much considered like an improper fraction. It's never simplified unless you actually go ahead and eliminate that. So the numerator, it doesn't matter if there's a radical up top. It's only if it's in the denominator. So for us to fix that, what we do is we look at the radical piece itself. And because it's the root of 6, what I want to do is I want to make that radical go away. And if I multiply it by root 6, that's going to achieve that. Okay, but if you do things to one side, you got to do things to another side. Okay, and then we start like kind of putting this all together. So on the bottom, you had that 3 that was out front, that still stays out front. And then you have this first 6, but you bring this 6 in with it. Okay, now I can break those down, each one to like 2 times 3, 2 times 3, circle my pairs. Or if you just see a pair of factors, then that's all you got to circle, and out comes one of them. So out comes that 1 6 and multiplies with that 3, and that gives us 18 on the bottom. Okay, up top we have this 3 that was still there, and then I'm going to break it down now because these are not the same factors. So for 9, I had 3 times 3. And the square root of 6 we know is 2 times 3. So if I circle that 3, out comes one of them. So I take this 3 times the 3, which is 9. And if you notice here, we got this 2 times 3 underneath. They don't have pairs that match up with them. So we just multiply them back together, and we get 6. So right now we're at 9 root 6 over 18. However, your whole numbers, your coefficients out front, those can reduce. Okay, so 9 over 18, I know those are going to reduce. 9 goes into 9 once, goes into 18 twice. So my final answer is going to be root 6 over 2. And this is not going to reduce because this 2 is not in a square root symbol or anything. So this is as broke down as far as you can go there. Again, this answer is okay because we no longer have our root symbol in our denominator. Okay, number 2. So let's start off. Let's just multiply by the denominator itself, the radical there, the root of 10. So I come up top, multiply this by root of 10. So what happens is you have this first 10 placed with the second 10. So there's my pair. Out comes one of them, and there's nothing left underneath. So it's just 10 remaining on the bottom. Okay, up top, we have the 3 from the front. And then you have this square root of 4, which we know we can break down into 2 times 2. And then 10, 2 times 5. See you, Dom. You want to make an appearance on camera?
Why not, I guess.
All right, everybody say hello to Dom.
Hi, random person's watching this sad puzzle.
See you
I'm going to be watching this. Oh, frick, I get to see myself. I'm leaving.
See you, buddy. Okay, so 2 comes out as multiplied with that 3 there. So then we have 2 times 3, which is 6. And then we have this root 10, because from the 2 times 5, over 10. Now, this 10 cannot reduce with that 10 because they're totally different. One's under a radical symbol, one's not. However, the 6 and the 10, those are going to reduce because they're both even. So if I cut those in half, I get 3 over 5, and that's as far as it's going to go. So my final answer is 3 root 10 over 5. Okay, number 3, starting off, if we look down here at the bottom, the root of 5. Again, I don't really care about that whole number. It's this root here, this radical, that's making that an improper fraction. So I need to multiply by a root 5 to make that eliminate. Come over here, multiply by a root 5, which means you still got that 4 out front. And then you have the 2 root 5s you place together underneath one larger one. Up top, the square root of 4, well, that's 2 times 2. and then we had multiplied by the root 5, all underneath one large radical symbol. Okay, circle my pair, out comes one of them. So 5 multiplied by that 4, that gives us a 20. Here's a pair, out comes one of them. So there's a 2 for that, and then you just have that root 5 left. And then, again, these whole numbers are going to reduce. So 2 goes into 2 once, goes into 20 10 times. So our final answer is root 5 over 10. Okay, number 4, identify the radical symbol in the denominator, which is a root 5. So we're going to multiply by that to both sides. Almost looks exactly like the last problem, except one number is different. Okay, so I have 2 from there, and then my 2 root 5s together. Up top, what we already talked about, that's 2 times 2 over here times that root 5. So I know from my last answer over here, this is going to simplify to 2 root 5. And then on the bottom, out comes that. So 5 times 2 is 10. And 2 and 10, those reduce. So 2 goes into 2 once, goes into 10 5 times. So final answer is root 5 over 5. And again, you cannot reduce those because one's outside the radical symbol, one's inside. Okay, number 5. So we'll notice on number 5, things are going to get a little bit trickier here because it's not just a single term that's up top here. We have this binomial up top here. Okay, so we're going to multiply by a root 8. Multiply by a root 8. Okay, on the bottom, you had this 3, and then we had the root 8 for the first one times the second one. Now, up top here, you got to apply distributive property. So root 8 times 2 gives you 2 root 8. And then root 8 times a root 3, that's technically a root 24. And that's a plus sign in the middle there. Okay, so simplify. So out comes an 8. And 8 times the 3 gives us the 24 on the bottom. Okay, 2 root 8. So this is going to break up. 8, is 3 2s. And then my 24, so plus the root of 24. And, lots of different ways you can break that up. 8 times 3, 6 times 4. So if I'm doing 3 times 8, well, there's my 3 times the 8. So 8 was 2 times 2 times 2. Okay, then let's simplify further. So this 2 comes out, multiply by out front there, and 2 times 2. So we got the 4 root 2, because you had that 1, 2 that's left there. And then over here, we have a pair of 2's that's going to come out. So plus 2, and then 3 times 2 gives you root 6. Okay, and then we have all over 24. This is not reduced because this can reduce with just the whole numbers. Like I'm not really concerned about the radical symbols. Those just kind of stay away. This is the same thing as if I would have said this. If I say 4 root 2 over 24 plus 2 root 6 over 24, that's the exact same thing. So I can reduce these pieces with this, okay? So 4 and 24 and 2, well, they're all even. Okay, so if I'm going to just simplify this, I know if they're all even, I can cut them in half. So half of 2, I got my root 2 for that. Half of 2 is 1, which I don't need to write that, plus root 6. On the bottom, half of 24 gives you 12. So we get 2 root 2 plus root 6 over 12. Okay, number 6. I see on the bottom, I have this square root of 15, so I'm going to multiply by square root of 15 to everything. Okay, so on the bottom, essentially what happens is, you just make one big one. Out comes your pair, which is just 15. Okay, up top, we got distributive property going on. So 2 times root 15. And then over here, we have this 2. So plus 2. And then we have 3 and 15 together. So root 3, and then 15 is 3 and 5. Okay, now with this 3, that pairs up. Out comes one of them. So 3 times 2 is going to give us 6. Okay, so I have 2 root 15, because root 15 is not going to break down anymore, plus 6 root 5, okay, over 15. Now, 2 doesn't go into 15. There's no common factors there. 6, your common factor would be 3, but I can't reduce that with this one unless I break it apart. So there's 2 different ways you could write this. It could just be left like this, or you could have separated it like this. 6 over 15, 3 goes into both, so 2 root 5 over 5. Okay, but I believe all the answers, they're going to just like leave it in this format, okay? But again, these 2 would be equivalent. All right, number 7. So I am running out of room here a little bit. So I'm going to multiply by the root 6 to both sides. And I know on the bottom, those 2 6's come together. That's just going to leave you a 6 that comes out. Okay, do distributive property. So this time you had a 4 that's up top. And then this root 2 is coming in with this root 6 that's being multiplied. And then we have this plus the root 5 being multiplied by the root 6 coming in. Okay, so this is going to break down a little bit. We got 4, and then there's my 2. 6, there's 2 times 3, plus, if you look at this root, so 5 and 6 is, 2 and 3. Well, there's going to be no common factors there, so you can just put that back together. That's going to give you 30, because 5 times 6. Again, all over 6. So here's my pair. Out comes 1. Okay, so 4 times 2 will give us the 8. And we have 8 root 3 plus root 30 over 6. Again, I'm going to leave it like this one. I don't want to separate it. The 6 and the 8 could reduce, but because that's technically a 1, that's not going to reduce any further. So I'm going to leave that one as my final answer. And we'll do one more. That is number 8. So we're going to start off, and we're going to multiply by the square root of 3. Okay, which means got a pair of 3's. Out comes just one of them. Up top, we do distributive property. So 5 times root 3 is 5 root 3. And then minus. So I have 3 here. And then root 2 times root 3. Okay, so 5 root 3 just comes down. Over here, there's no common factors there. So 2 times 3 just gets multiplied together. So that's minus 3 root 6 over 3. Again, I check if I can reduce, but these 3's would reduce, but the 3 and the 5 doesn't. So I'm just going to leave that as my answer. 5 root 3 minus 3 root 6 all over 3. Okay, you guys go ahead and do number 9. Number 10. Number 11. 12. Number 13. 14. 15. 16. 17. And 18.